Alright guys, so this will be your video for how to find area using limits. So I'm going to show you two examples. One is going to be between your function and the x-axis, and the second one's going to be between your function and the y-axis. So here we go. So an example question is that we're trying to find the area between this function, so f of x, the vertical lines x equals 0 and x equals 1, and the x-axis. So in your problems online or anytime you see it on a worksheet, it'll probably look more like this line right here. So I wrote that out as well, so you can see where it's your function, your values that you're working between, and what you're trying to find the area between that function and what axis. So you might see it both ways, either written out or that shorthand version. So you do have an option to use either your little m sub I or your capital M sub I. Personally, your capital M sub I is going to be a little bit easier, so I would always suggest using that one, but you'd be correct if you use both. It's just one's going to be a little bit more challenging. So the first thing you always want to find is your delta x, your m sub I, and your delta x and your m sub I. So over here I have it on the side. Your delta x or your delta y is always going to be your interval divided by n, so b minus a over n. So it's 1 minus 0 over n, 1 over n. And you can see your m sub I becomes I over n. So we are going to put them into our formula here. So remember, there's some things that just can't not be written. So you have to always write your limit as n approaches infinity until you actually plug in infinity. You always have to write your summation formulas or your summation notation until you use your summation formulas. So I should always see those two notations until it's appropriate for you to apply that step. So here you go. So you can see I have my f of my capital M sub I, which is I over n, plus times my delta x. My function in this problem was negative 2x plus 3, so I have negative 2, and instead of x, I have my I over n plus 3 times my delta x. Now this one, like I said, your steps could always look a little bit different, but for myself, all I did was I distributed the 1 over n. And then in the next line, you can see that now I've applied my summation formulas, so you do not see your sigma notation anymore. So I applied my formula. I have negative 2 over n squared times I. So negative 2 over n squared, and this replaced I. And 3 over n is just a number. It's a constant, like c. So this is like your c times n. Simplify using some algebra skills. Get it as simplified as possible. You don't want to have to plug in infinity when you have it in multiple places, and you're going to actually end up with an indeterminate form, so you don't want that if you plug it in at the wrong time. So we have it separated, reduced, and now you see that I can't do anything else, and I still had my limit notation this whole time. Now I can plug in infinity. So when I do that, there's actually only one n that I'm going to be plugging it into. And you have to remember that if you have a number divided by infinity, that becomes 0, not infinity. So I saw that error a lot where we would write this as infinity down here. So remember, a number divided by infinity, it's kind of like you're cutting it up into so many tiny little pieces that it just basically doesn't exist. So it's 0. So you simplify and we get our actual area between my function, the x-axis, and between 0 and 1 is 2. Now let's look at a y version. Your steps are the same, the processes are the same. The only thing that's different is you're visually going to see y's. You're going to see f of y, you're going to see horizontal lines of what y equals, and you're also going to see delta y. That's the only thing that's different. Your steps are the same, the way you find delta y is the same, the way you find capital M sub I is the same. So do not be too worried when you get a problem that says the y-axis. It's the same process. So we're looking here and we have our delta y is 2 over n. Our m sub I is 2I over n. So that's all found exactly the same way as our last problem. Now let's look at our area. So notice how again I have my limit notation and my summation notation for many steps until I apply those rules. I'm going to be plugging 2I over n into my function. My function was 3y. So this 2I over n is going to replace my y. So 3y delta y, so 2 over n. Now this one's pretty nice because it's just all one term. We can just multiply. I get 12I over n squared. Notice how I still have my limit and summation notation. Now we can use our summation rules. So we know that we have 12 over n squared is just a number, so that goes in the front. And this replaces I. Simplify as best as you can. Break up your terms. When you do that, it makes it a little bit easier to simplify and to see what's going to become 0 and what will stay a value. So this simplifies to 6. This one simplifies to 6 over n. I still have my limit notation because I still have an n. I didn't plug in infinity yet. Now we can. There's nothing else I can do with this function to make it more simplified. So I have 6 plus 6 over infinity. 6 over infinity becomes 0. So my answer is just 6. So if I were to graph this function and kind of shade in that region between the function and the y-axis, I would be shading in a value of 6 units.